Welcome to math. Today's lesson's on binomial multiplication. Take a look at this question right here. This is something that you've done before. We call this multiplying a monomial, that's a monomial, times a binomial. Binomial meaning two terms. Okay? And when you had a monomial times a binomial, you just took this 2 and multiplied it by each part. We call this the distributive property. You're distributing the 2 into the brackets. Okay, so what we're going to do now is transfer that learning into what we call binomial multiplication. A binomial times a binomial. Two terms times two terms. Okay, and to do that, we're going to use the distributive property. First, you're going to take this x and distribute it into the second binomial. All right, and then you're going to take this 2 and do the same thing. So plus 2 and distribute it to x plus 3. So you're taking both parts of the first binomial and distributing them into the second binomial. All right, and here's what we get. We get x squared plus 3x plus 2x plus 6. Okay, so we've distributed it. Now, if you look at that closely, you'll see there are some what we call like terms. Like terms meaning having the same variable with the same exponent. These two terms are like. So we can further simplify this to x squared plus 5x plus 6. And this is what we call binomial multiplication. Multiplying two binomials together. Okay, let's check the next one out. Again, we're going to take the first term of the first binomial and multiply it by the second binomial. And then we're going to take the second term of the first binomial and multiply it by the second binomial. Okay, now we're going to use our distributive property. 2x squared plus 16x plus x plus 8. All right, again, there are like terms. And we get that. Okay, just a couple of notes of being particular. Make sure you have equal signs here, because what we've done is we've said, this line is equal to this line is equal to this line. All right, and these are expressions. This expression equals this expression equals this expression. Okay, these are not equations. All right, next one. This is probably, us math teachers have this book called How to Trick Students. Well, we don't really have a book, but if there was one, this would be in there. How do you trick students? Most common mistake is people see this squared and they go, oh, this is x squared and then 7 squared. This is incorrect. All right. What you need to do is think about what that squared means. Squared is repeated multiplication. This means x plus 7 times x plus 7. You see, there are brackets here. So this squared means that the whole thing is multiplied by itself. And now that should look familiar. We have binomial times a binomial. So you're going to have x times x plus 7 plus 7 times x plus 7. All right, and that is x squared plus 7x plus 7x plus 49. Like terms, we end up with that. Okay? By the way, that's considered a special case of the binomial multiplication. This next one is also considered a special case. You're going to see what happens when we multiply this. So let's distribute x times x plus 5 and then minus 5. Notice that minus sign has to be carried over here times x plus 5. And if I multiply, I get x squared plus 5x minus 5x minus 25. And now you should notice something strange. 5x take away 5x. And there's no more middle term. I would put a star by this in your notes, okay? this is a special case when you have two binomials that are the same, except that the sign between them is different. We have a plus and a minus. This is called difference of squares. Okay, you're going to see this over and over again, the difference of squares. And these two binomials, they're a special kind of binomial. They're called conjugates. Okay, I'm not really worried if you don't memorize that word, but you're going to hear that again. They're conjugates. They're the same binomial with different signs in them. All right, let's get a bit harder. Okay, you can see this is not a binomial times a binomial. It's actually a binomial times a trinomial. Okay, a binomial times a trinomial, good news is we're going to do the same thing. We're going to take the first term of the binomial and multiply it by everything that's in the second term, or the trinomial. And then we'll take the plus 4 and also multiply it by everything that's in that second bracket. Okay, so let's multiply. Okay, and if we now put this all together, collecting all like terms, we end up with 8x squared, 18x plus 8. All right, there is the lesson on binomial multiplication. Now, for some of you guys are saying, hey, you know something, I think that I can skip this first step. This first step, I don't know if I even need to write that out. I think I can see that. All right, and what I'm going to do is show you that shortcut. We call this the FOIL method. Basically, this is the distributive property. All right, and all it is saying I don't need to write out the distributive property. I can do it in my head. Okay, let me show you what I mean by that. If we look at what we did in this line right here, all right, what we're doing is we're saying this x times x, this is the first term times the first term in each binomial. Okay, this x times 5, this is the first term times the second term. We call these the outside terms. All right, and if we continue that, you're going to see what I mean when I write FOIL. Okay, so I want you to write the letters here. F-O-I-L. Okay, F means the first terms. The first terms are x times x. All right, then the outside terms. The outside terms are here. X times 7. All right, the inside terms, those are the ones that are in the middle here. We got a negative 4 times x, so this is negative 4x. And the last terms are the two last terms in the binomials, the two numbers in this case, so negative 4 times 7. Okay, now do you see where I got all those terms? Okay, let me back up a little bit. Let's say I'm not going to write out, I'm not going to do it like that. Okay, instead, what I'm going to do is show you the distributive property. We'd have x times x plus 7 minus 4 times x plus 7. Now watch what happens. The first terms, x squared. Okay, the outside terms, we'd have x times 7. The inside terms, negative 4x and negative 28. Those are the same things that we had just written a minute ago. Okay, so just simplifying, you'd have... All right, let's try it again with FOIL. So the first terms, 2x times x. This is 2x squared. Then the outside terms, 2x times negative 5. This is negative 10x. Then the inside terms, 3 times x. And then 3 times negative 5. So would look like that. Now at this point, you got to say to yourself, hey, do I like this method, or do I feel more comfortable doing it the way with distributive property? I don't care. You can do either one. It would be totally up to you what you choose to do. I know that some of you right away are always looking for a shortcut, one way to, not write that one step. It's up to you. Both ways are correct. I think that if you do enough of these, you're going to try to do this in your head. Okay? So remember that this is the trick here, x minus 3, x minus 3. If I FOIL this, all right, and by the way, you might want to pause the video right now and try this, see if you can do it on your own. Okay, when you come back, first terms, x times x, x squared. Outside terms, x times negative 3, that's negative 3x. Inside terms, negative 3 times x, this is negative 3x. And last, negative 3 times negative 3, 9. So you get x squared minus 6x plus 9. Okay, next one. Do you recognize what's going on here? Do you remember why I called those the conjugates? And do you remember what happened when we multiplied two binomials that had the same terms but different signs? Well, let's see what happens. FOIL, F. First terms. Next we have the outside terms, so x times 6. Then we have the inside terms, and then the last terms. And do you remember what happened with conjugates? Those middle terms will cancel out. Okay, last example for today's notes. Binomial times a trinomial. And here's the problem. FOIL doesn't work with this. The letters FOIL will only give me 4 terms. You should recognize that if I multiply 2 terms times 3, at first I'm going to get 6 terms. So FOIL doesn't work here. So you can go back to the distributive property. But let's try and do the distributive property in our head without writing out that step. You see, what we would do is we would say, well, let's go x times the trinomial, and then we would go 2 times the trinomial. But you don't need to write that step out. We can visualize x times each of these terms. So we would get x cubed minus 5x squared plus 3x. Okay, and now let's take the 2 and multiply it by each of those terms. So you would get 2x squared minus 10x plus 6. Combining like terms. And we're done. Okay, so what you need to do now is you need to go to exercise 2 in our cumulative booklet, and you can complete those questions.